A very warm welcome to all the students of class 7th. In this video, we will revise chapter 7, which is acids, bases and salts. So children, what is an acid? An acid is basically a compound which contains hydrogen atoms which can be replaced either wholly or partially by metal atoms or positive radicals. And this term acid, it has been derived from a Latin word acidus, which means sour. So, everything that tastes sour contains an acid. Actually, there are two types of acid. The first one is organic acid and the second one is inorganic acid. So, the acid which we eat are organic acids and the inorganic acids are used in industries and they have biological uses as well. Children, these are some common organic acids. The foodstuff is tomato and the acid found in it is oxalic acid. Then curd. The acid is lactic acid. The third one is vinegar. The acid is acetic acid. And the fourth one is grapes. And the acid found in it is tartaric acid. Now, these are some common inorganic acids. The first one is hydrochloric acid. So, hydrochloric acid is basically used as a bathroom cleaner and it is also used in dyeing and textile industries. Now, this next one is nitric acid. Nitric acid is used in the manufacturing of rayon and also in the manufacturing of dyes and drugs. Nitric acid also forms nitrates in the soil from which the plants derive nitrogen. The third one is sulfuric acid. Sulfuric acid is used in lead storage batteries. It is also used in the manufacturing of hydrochloric acid, alum, fertilizers and detergents. The next one is carbonic acid. Carbonic acid is actually the sour component of the fizzy drinks. The last one is phosphoric acid. So phosphoric acid forms a part of phosphoric fertilizers. Now, what are concentrated and diluted acids? So, if the solution has a large amount of acid in it, then it is known as a concentrated solution. Whereas, if a solution has very small amount of acid in it, then it is known as a dilute solution. The next one, what are the characteristics of an acid? So, an acid is sour. Second one is, it turns blue litmus red. Then the third one is, an acid corrode most of the metals. And the last one is, when acid reacts with base, they lose their acidic properties. Now, what is the action of acids on carbonates? So, what happens when acid reacts with carbonates? They give carbon dioxide with effervescence. So, let us look at an example. The first one is hydrochloric acid combines with sodium carbonate to give sodium chloride, water and carbon dioxide. Similarly, sulfuric acid combines with calcium carbonate to give calcium sulfate, water and carbon dioxide. Now children, the displacement of hydrogen from acids by metals. See, there are some metals in the activity series which are above the hydrogen. So all those metals which are above hydrogen in the activity series can easily displace hydrogen from the aqueous solution. So let us read what is written here. Metals like potassium, calcium, sodium, magnesium, aluminium, zinc and iron. All these metals are more active as compared to hydrogen. So they can easily displace hydrogen from an aqueous solution. But only magnesium and manganese can displace hydrogen from nitric acid. Now the reaction is given here. Magnesium combines with hydrochloric acid to form magnesium chloride and hydrogen gas is liberated. However, there are metals like copper, silver and mercury. These are less reactive than hydrogen. These are lower than hydrogen in the activity series, so they do not displace hydrogen from an acid. But if they undergo chemical reactions, then they will also easily get corroded by the acids. This is the reason we do not store acids in the metal containers. Now children, what are bases? Bases are actually the compounds that react with acid to form salt and water. So these bases are usually the oxides and hydroxides of metals. The examples are sodium oxide and calcium oxide. So soap and toothpaste, these are two bases which we come across in our daily lives. Now alkalis. Soluble bases are known as alkalis. For example, sodium hydroxide and potassium hydroxide. So the bases which are soluble in water are known as alkalis. The examples are sodium hydroxide and potassium hydroxide. Now, bases like magnesium hydroxide is not soluble in water, and that is the reason it is not an alkali. Now, there are some bases which are not soluble in water, and that is the reason it is not an alkali. So, we can say that all the alkalis are bases, but not all the bases are alkalis. The exception we have already seen, magnesium hydroxide, since it is not soluble in water. All the alkalis are actually bases, but all the bases are not soluble, that is why they are not alkalis. The next we have is neutralization reaction. So a neutralization reaction is a reaction in which an acid and base combine to form salt and water. So what happens in this? Acid and base will combine and they will form salt and water. So in a neutralization reaction, what will happen? Acid will lose its acidic properties, whereas bases will lose their basic properties and they will become neutral. So an equation is given here. Sulfuric acid, which is an acid, combines with potassium hydroxide, which is a base, to form potassium sulfate, which is a salt, and water. So acid is combining with a base to form salt and water. The next one, salts. So salts are basically found in large quantities in the earth's crust, and there are a large number of salts that are dissolved in river water, and these are discharged into lakes and seas. So salts such as chlorides, bromides, iodides and sulfates of sodium, potassium, magnesium and calcium, all these salts are obtained from the sea water. In fact, the fruits and vegetables we eat, these are also rich in salts. For example, guava and apple. These are rich in salts, iron salts, and cabbage, it is rich in calcium salts. So the fruits and vegetables are also rich in salts. Now here are some salts and their uses. So the first one is sodium chloride. Sodium chloride is basically used as a flavoring agent in food, and it is also used for a patient of dehydration. Sodium chloride is used in the manufacturing of hydrochloric acid, washing soda and caustic soda. Now the next one is sodium carbonate. Sodium carbonate is used as washing soda, and it is also used in the manufacturing of glass. Now the next one is potassium nitrate. Potassium nitrate is basically used in matchsticks and as a fertilizer. The next one is calcium carbonate. Calcium carbonate is used in the cement industry. It is also used in the construction of buildings and in the extraction of metals. Then the last one is alum. It is used in the dyeing industry and it is also used as an aftershave applicant. Now, these are the salts and their occurrence. So the first one is sodium chloride, and it is found in rocks of common salt. Then the second one is calcium carbonate. It is found in all the soils and limestone rocks. Then the third one is calcium phosphate. It is also found in all the soils and phosphate rocks. And the last one is potassium aluminium silicates. So it is basically found in all the soils, mica and china clay. Now, pH scale. So, in what happens in an acid base indicator, it will help us to know whether the solution is acidic or basic. But it does not tell us that how acidic or how basic a solution is. So, if we have two solutions which are acidic in nature, so acid base indicator will only tell us that it is acidic in nature, and it will turn red in both the cases. But we do not know which one is more acidic and which one is less acidic. So the pH of the solution tells us that which of the solution is more acidic and which one of the solution is more basic. So the pH scale actually runs from 0 to 14, and a neutral scale has a pH of 7. So if the pH is 7, then it is neither acidic nor basic. If the pH is less than 7, then we can say that it is acidic in nature, and the acid content increases with the decreasing pH. For example, a solution of pH 2 is more acidic than the solution of pH 3. Now, the solutions which have the pH more than 7 are basic in nature, and higher is the pH value, higher is their basic. The higher the basic are, right? For example, a solution which has pH value of 12, it is more alkaline than the one which has pH value 11. But we should always remember that pH is only useful for dilute solutions, not for concentrated solutions. When we started, I told you what concentrated solutions are. So concentrated solutions are those which have a large amount of acid in it. So pH is only suitable for the solutions which are dilute. Now, how do we measure pH? So the pH of a solution is generally measured by a strip of pH paper. When it is treated with a solution, the strip will give a particular color, and you can match the color with the printed chart showing different colors for different pH values. So you can see the chart here and you can match whatever the color is, and then you will get the pH value of the solution. Now we are given with some liquids and their pH value. The first one is apple juice, its pH value is 3.0. Then the second one is coffee and its pH value is 5.0. Third one is lemon juice, its pH value is 2.5. The next one is milk, its pH is 6.5. Then vinegar, its pH is 3.0. Here is the revision test of the chapter. Take out your notebooks and write the answers of the following questions. The first one is define. First part acid, second part base, and the third part is neutralization reaction. The second question, the pH of blood is 7.4 and that of a toothpaste is 9.0. Which of the following is more basic? The next one, is the pH of lemon juice higher or lower than 7? Fourth question, are all the alkalis bases? You have to write yes or no in the fourth part. Fifth part, you have to write the uses of sulfuric acid and alum. All these questions I have just discussed. So write down the answers. That's it for the day. Goodbye and take care.